Artificial Intelligence Reflection. Overview. Learning objectives. By the end of this unit, you will be able to understand what is artificial intelligence and its real-life applications. Learn the importance of iterative problem scoping in AI projects. Understand about the data and how to acquire it from reliable sources. Identify important data features used in AI. Use data visualization to analyze and present data effectively. Understand AI, machine learning, and deep learning. Learn the difference between rule-based and learning-based models. Evaluate AI models for efficiency and accuracy. Calculate model accuracy and error using true positive, true negative, false positive, false negative. Understand how to deploy AI models in real-world systems. Applications of artificial intelligence. In everyday life. Voice assistants. Siri, Alexa, and Google Assistant help with tasks like setting alarms or searching the web. Recommendations. Netflix, Amazon, and YouTube suggest movies, products, or videos based on your preferences. Smart devices. Artificial intelligence powers smart home systems like thermostats and security cameras. Healthcare. Diagnostics. Artificial intelligence helps doctors detect diseases like cancer through medical imaging. Personalized medicine. Artificial intelligence predicts the best treatments for individual patients. Robotic surgery. Robots guided by artificial intelligence assist in complex surgeries with precision. Education. E-learning tools. Apps like Duolingo use artificial intelligence to personalize lessons. Automated grading. Artificial intelligence can grade tests and assignments quickly. Virtual tutors. Artificial intelligence chatbots provide students with instant help. Transportation. Self-driving cars. Companies like Tesla use artificial intelligence to enable vehicles to drive themselves. Traffic management. Artificial intelligence optimizes traffic flow and reduces congestion. Navigation. Google Maps uses artificial intelligence to provide accurate routes and real-time updates. Business. Customer service. Artificial intelligence chatbots handle customer queries 24/7. Fraud detection. Artificial intelligence identifies suspicious transactions in banking. Market analysis. Artificial intelligence helps businesses analyze trends and predict future sales. Entertainment. Gaming. Artificial intelligence opponents adapt to your gameplay in video games. Content creation. Artificial intelligence can create music, art, or even write scripts. Visual effects. Used in movies to generate realistic special effects. Agriculture. Crop monitoring. Artificial intelligence uses drones to check the health of crops. Predicting weather. Helps farmers make better decisions about planting and harvesting. Smart equipment. Artificial intelligence-powered machines plant and harvest crops more efficiently. Security and defense. Facial recognition. Used in security systems to identify individuals. Cybersecurity. Artificial intelligence detects and prevents hacking attempts. Defense systems. Artificial intelligence helps in surveillance and strategic planning. Iterative nature of problem scoping. In an AI project, the problem scoping phase is very important. If it is not done properly, the whole project can fail. The iterative process is a method used in problem scoping to keep improving an AI model. It means creating a basic version, testing it, and then repeating the steps until the final model is ready. Benefits of the iterative process. Each time you repeat the steps, you can fix problems found earlier. It saves money because you find problems early and keep checking the project. It's easier to test and fix small parts at the beginning. You can show progress to clients and others after each step. Data acquisition. Data acquisition means collecting raw facts, numbers, or information from the right sources. This data is used for studying or for building AI projects. In the AI project cycle, data acquisition is the second step. It takes a lot of time because different types of data are found in many places, and we have to collect only the data that matches our project needs. What is data? Data is raw information, like facts or numbers. It needs to be processed to become useful. In AI projects, we need data to train the system so it can make predictions. Data is the base of any AI project. There are two main types of data. Training data. This is the data used to teach the AI model. The correct answers are already included in it. Testing data. This is new data used to check how well the AI model works. The model hasn't seen this data before. Example, if we want to build an AI model to predict the average marks of students, we will give it marks from past years. Then, we will test the model using new marks to see if it gives correct predictions. Data features. When we collect data for an AI project, we need to make sure it is useful. We should think about what factors affect the problem. Data features are the different parts of the data we want to collect. Example, subject-wise average, number of students, theory and practical marks. Reliable sources of relevant data. Good data must come from trustworthy sources to make the AI project accurate. Some reliable sources include surveys, collecting answers from people using forms or questions. Web scraping, collecting information from websites. Sensors, devices that collect real-time data like temperature or pollution. Cameras, collecting data as images or videos. Observations, watching and recording events as they happen. Application programming interface, tools that help one software collect data from another. Note, we should never use private or fake data. It's best to use data from official government websites like data.gov.in or india.gov.in because they are safe and reliable. Data visualization. Data visualization is the way we show data and information using pictures, like charts and graphs. It makes it easier to see trends and patterns in the data. We can do data visualization using both automated tools and manual methods. It helps to organize scattered data into a clear pattern and helps us see important trends. It also helps us make better decisions. Why do we need to explore and visualize data before using it in an artificial intelligence model? Understand trends. Visualizing data with graphs grabs our attention and makes it easier to see patterns. Numbers alone can be hard to understand, but a chart helps us see trends quickly. Deciding which model. Humans understand visuals better than tables of data. Data visualization tools help us make decisions faster, which helps businesses grow. Easier to comprehend. Visualization helps us understand large amounts of data that would be hard to read in rows. A good visualization tool helps clean up the data and highlight important information. Easier to communicate. Visualization helps us share lots of data with others in a simple way. Interactive tools make it easy to explain findings and important information to others. Why is data visualization needed? It simplifies complex information. It helps us analyze and explore big data easily. It helps find areas that need improvement. It shows the relationship between different data points. It reveals new and hidden patterns in the data. Data visualization tools. There are tools for both manual and automated analysis to help us visualize and understand the relationships between different sets of data. Here are some commonly used tools. Microsoft Excel. This is a tool from Microsoft for manually exploring data. It can create basic charts and graphs to visualize small data sets. But it's not good for very large data. Tableau Public. This free software helps create interactive data visualizations that can be shared with others. It works well with large datasets and is very popular for data visualization. Microsoft Power Business Intelligence. This tool, provided by Microsoft, helps visualize data and is free to download and use. Data Wrapper. This tool is often used in the media industry. It uses comma-separated values files to create charts and maps. Google Data Studio. Part of the Google marketing platform, this tool helps create different views of your data. Other websites also offer data visualization tools, like this website provides various types of graphs and flowcharts for data visualization. What is modeling? Modeling. Modeling or data modeling is the process of creating a decision-making system. This system learns from the data collected earlier and uses that learning to find patterns. After making graphs and understanding trends from the data, the next step is to build an artificial intelligence model using algorithms. We can create our model or use one that already exists. Before learning more about modeling, let's understand some important terms. Artificial intelligence. Artificial intelligence is a technology that helps machines act like humans. These machines can do tasks on their own once they are programmed. Artificial intelligence allows computers to think and work without needing human help. Machine learning. Machine learning is a part of artificial intelligence. It helps machines learn from their past experiences. Machines use data to improve their performance over time. Examples: Snapchat filters, Netflix movie suggestions. Deep learning. Deep learning is a part of machine learning. It uses a large amount of data to help machines learn better. It works like the human brain, using special units called neurons. Examples: Google Translate, face detection in social media apps. Artificial intelligence is an umbrella term that holds machine learning and deep learning. Deep learning follows a specific learning approach, which is a subset of machine learning, comprising multiple machine learning algorithms. Difference between artificial intelligence, machine learning, and deep learning. Artificial intelligence. AI aims at making a machine that mimics human intelligence. It is a subset of data science. It is the simulation of in machines. Machine learning aims at making a machine that can learn through data and solve complex problems. It is a subset of data science. It is the training of machines to take decisions with experience. Deep learning aims at building neural network that can help in discovering patterns or trends. It is a subset of machine learning. It is the process of using artificial neural networks for solving complex problems. Data modeling techniques. In artificial intelligence, we create algorithms that help machines give smart results. This means we write code that makes machines act intelligently. There are two main ways to build these models: rule-based approach, learning-based approach. Rule-based approach. In this method, the machine is given a set of rules and facts. The developer tells the machine how to use the data. This method works with simple and clear data. Example: You have 100 pictures of cars and 100 pictures of cycles. You tell the machine which picture is a car and which is a cycle. Now, if you show a new picture of a car, the machine compares it with the old ones and tells it's a car. This is a rule-based approach because you gave it clear rules. Learning-based approach. Here, the machine is not given any rules by the developer. The data is random and not labeled. The machine finds its own patterns or trends from the data. Example: You have 1000 pictures of flowers, but you don't know their names or features. You give all these pictures to the machine without any labels. The machine studies the pictures and groups them based on things like color, shape, or size. Sometimes, it may even group them in ways we didn't think of. AI project evaluation. Evaluation is the final step in an AI project. It checks how well the AI model works, including its efficiency and accuracy. This step helps improve the model to reach the project goals. To make this happen, certain hardware and software settings need to be adjusted, so the artificial intelligence model can be used effectively by the end users. Artificial Intelligence Project Deployment. Deployment is the process of using the artificial intelligence model in the real world. It means integrating the model into an existing system so it can work with actual data and provide the desired results. To make this happen, certain hardware and software settings need to be adjusted so the artificial intelligence model can be used effectively by the end users. Accuracy and error. Accuracy tells us how many predictions made by a model are correct out of all the predictions it made. Understanding correct predictions. True positive, model correctly predicts a positive case. True negative, model correctly predicts a negative case. False positive, model predicts a positive case but it's wrong. False negative, model predicts a negative case, but it's wrong. So, accuracy is calculated as accuracy is equal to true positive plus true negative divided by true positive plus true negative, false positive plus false negative by 100. Why accuracy can be misleading? Imagine a disease prediction where 95 out of 100 people are healthy. If a model always says healthy, it will have 95% accuracy, but will fail to identify the 5 sick people. Error rate. Error rate shows how often the model is wrong. A high error rate means the model is making many mistakes. Formula. Error rate is equal to 1 minus accuracy. Or error rate is equal to false positive plus false negative divide by true positive plus true negative plus false positive plus false negative. Together, they help us understand how good the model is. Example. If your AI model predicts the correct result 8 out of 10 times, the accuracy is 80% and the error is 20%. Higher accuracy and lower error mean a better model. AI ethics practiced while designing AI projects. When creating an AI model, it's important to follow some ethical rules. The model should be easy to understand for everyone. Everything about the model should be clear and easy to explain. The model should include and be fair to all groups of people. Check and confirm that all assumptions and results are correct. Keep checking how the system is working because problems can happen, and it's important to find them early. Decide who is responsible for the system and who will fix any issues.